Hey everybody, today I'm going to be doing Spaced Out. This is a silver problem from the problem 30 from January. I'm about to finish the January contest. Hopefully I can explain this well. But the idea is pretty interesting. Please don't lag on me. You're lagging on me. There we go. Just clear. Okay. So like I said, the idea is pretty interesting. And so you're going to give an n by n grid. So they're going to give you, in the test case, I think, or the sample test case, it's going to be a 5 by, or maybe a 4 by 4. I think it was. I think it was a 4 by 4. But I remember it like this. Let's see if I memorized it correctly. Ha. Yeah, there was a pattern, so it was pretty easy to memorize. So it's an n grid, or n matrix. And so the idea is you want to, so for every 2 by 2 rectangle within this kind of matrix, you can choose two places, take the sum of them, and you can add it to your total. Alright, so I guess the maximum would be 3 and 3. You get not 9, 6. And so, yeah, so for every 2 by 2 sum matrix inside the matrix, you can choose two indices where you can add to your total. So for here, I can add this guy here, so plus 3, that'd be 9. I can add 2 here, 6, so 15, and then add 2 here, and I get a total of, oh, also have to add this one here. So I get a total of 22. That's the maximum amount. And so basically your goal is to get the maximum amount such that you select two, I guess, cows for every 2 by 2 matrix. Now the trick is you can only choose two. So I can't choose these 4 guys because this 2 by 2 matrix has 4 people. Okay, even though, like let's say I just choose this, even though this is 2 by 2, this is 2 by 2, this is 2 by 2, this middle 4 by 4 is, but yeah, this little 2 by 2 has 4 possible, or 4 people chosen. And so, yeah, that can be pretty hard to keep track. So remember, every 2 by 2 sub matrix has to be selected. And you also have to find the maximum as well. So, yeah. I think I explained that well, or okay. So let's just like find some patterns of that. Let's just like look for some patterns. So I guess, can I not move to the right? Oh my god. Okay. Yeah. So let's find some patterns. I'm gonna draw these dots. Actually, oh, you know what? That's perfect. I can use these squares on here. Okay, so this is gonna represent here. It's just gonna be a little bigger. So let's just see like what I can pick out. So I can pick out these two in this kind of fashion. Yeah, so every subgrid is 2. That's a good way. The optimal way is to pick it like this. Okay. Like right now we're trying to figure out what are like possible ways such that every 2 by 2 sub matrix only has 2 people chosen. So maybe like this. I think it's fine. Or is that right? Oh, this middle one has none, so that's actually incorrect. Maybe like this. And if you're not seeing the pattern, I'll do one more. There is a pattern. At first, I actually thought of doing every single possible 2 by 2, or every single possible rectangle, or something like that. I'm just brute forcing it, but brute force is slow. It's always slow. Be like this. No, I can't do it actually. Actually, wait. Can I do this? I can. Maybe I just want to do this. This is also possible. Or I can do vertical as well. Yeah, that works as well. Well, so what you'll notice is a total of n times 2 places will be chosen every time. And that's because n times n divided by 2 are, yeah, I think it's, wait, no. It's n squared divided by, what would be divided by 2? Huh. I actually don't know. Never mind. Don't quote me on that. No. But the idea is you'll notice that you can only pick like, let's just go like rows, for example. That's an ugly arrow. Let's go rows, for example. You can only pick every other, right? So you can either pick 1, 1, or 3, 3, and both these work. This for this first row. Oh my gosh. So for this first row right here, I can only pick either 3, 3 or 1, 1. Right? And I can't pick 3 because what's going to happen is I'm going to have a discrepancy right here, or maybe even here. So for every row or column, I can only pick 2. Or yeah, for every, like, if we're only considering vertical possibilities, we can only choose like every 2. Right? It's going to be hard to understand, but hopefully you'll get it. So here vertically, I can pick 3 and 3, and 1 and 3. Right? I can't pick 1 and 3 because this. And so they have to be every other, right? So you'll notice that parity is involved, or odds and evens. And so I can either pick odds or I can either pick evens. Right? Same idea here with the idea of picking by row, or yeah, picking by column, which is this way. So let me just, I love how my computer is very slow. Actually, I'll just erase that. Yeah, I'll erase this one too. So yeah, I can only pick by row or column. Let's just pick by column in this case. So I can pick these two, maybe these two, maybe I'll do this again, and these two, and like, yeah. So you can only do like in the same parity. If you're picking by row, or if you're picking by row, like in this case, you can do parities in this fashion over here. If you're picking by column, you can only pick in this fashion. So what I mean by this fashion is for columns, you can only combine even and odd columns, and for by row, you can only pick even and odd rows. So yeah. So in this case, it's by column. So you'll notice only evens go with evens, odds go with odds. And so that's kind of the idea. Those are the only ways to make a valid solution out of this. Yeah. So yeah, knowing this, we can literally just brute force all possibilities. And this is kind of stupid, but you just had to make this observation. So the idea is we make a matrix. This is by a matrix. I just read it as input. And so I loop through all of n, and I loop through n again. And so if j is even, so in this case it's by column. If it's even, or this is by odd actually. This is if it's odd, I add it to T2. If it's even, I add it to T1. T1 is just temporary variables. And so I just take the max out of them. And so for every row, I'll just take the max out of it. So in this case, like, okay, yeah. Yeah, so I'm gonna undo everything. So I could either take 3 and 1 or 3 and 1 in this case. So either way, it's fine. I just take the max. In the second row right here, I can either pick 1 and 3 or 1 and 1, and I'm obviously going to pick 1 and 3 because that's bigger. Add that, and here I can either pick 3 and 1, 3 and 1, and so on and so on and so on. So this is going to be choosing by column. Okay. And then here, I choose by row. So you notice how J is in the front right here. So I'm going to choose by row, and I can either choose 3 and 3 or 1 and 1, which I'm obviously going to be choosing 3 and 3. I can choose 3 or 3 or 1 on 1, and 3, 3, or and 1, 3. Those are the best possible. So yeah, I just basically brute force all the possibilities. I think there's only there's multiple possibilities, but yeah, then you just take the max of A and B. That's kind of the whole solution. And if you're kind of mad that you couldn't figure out a really easy solution, which I was really too, don't worry. And in order to notice this type of stuff, just like draw out test cases. Draw out like a bunch of examples, see any patterns of like successful version, and see if they work. And if they do work, keep that pattern inside your brain. And really, competitive programming is just about like finding patterns. That's kind of it. This is the definition of patterns. I like this problem a lot, even though it makes me mad that I couldn't solve it during the contest because I wasn't really trying at USACO at that time. But yeah, it's a very interesting problem and I like it a lot, but it also pisses me off at the same time. So I'll just submit it at the end. It's a very easy solution, but I guess like a tough problem to think about. And it's spaced out. I would officially say this is maybe my favorite problem. I don't know. I have like a love-hate relationship with this guy. Or girl. I don't know what you're gonna call it. But shoot. Oh no, I think I just put in C. Something like that. It's not C17. Spaced out. Yeah, this also has 20 test cases, surprisingly, which is pretty crazy. Oh, I see. So here, usually in order to get partial credit, you could probably do like maybe 2 to the n. Yeah, so I got it all. But for partial credit, you could probably do like, please load. Okay, there we go. For partial credit, you can do 2 to the n squared. And so what I mean 2 is that there's 2 times 2 times 2 dot 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 n times 2 times 2 times 2. So the two possibilities are whether you use it or whether you don't. And then you could also make like another check whether it's like passing all the qualifications. And when I mean qualifications is like every 2 I do subgrid has only 2 people chosen. So that is possible. I think you would get partial credit maybe 2 to the 2 right here. 2 to the 4 squared is 16. I think that's going to pass. To the 10, 100 squared, that's not going to pass. No. It's only going to pass that. But yeah, this is a open squared solution. So yay. But yeah, that's it for January. Hope you had a great time. And yeah, see you in, I may do December. I probably will do December. But yeah, see ya.